Welcome all of you in this tutorial of PCA versus tsne. In this tutorial, we are going to see the comparison between two-dimensional reduction techniques such as PCA and tsne using one complicated dataset, that is breast cancer dataset, and we see in which situation PCA is better and in which situation tsne is better. So let's see. First of all, we import all the libraries which are required for our analysis. So these are the all libraries which are required for our analysis. So let's execute our code. Our code is executed. Now we import our dataset, that is breast cancer dataset, consists of 32 variables and 569 rows. So in this data we can see this is our target variable, that is our target variable consists of the brain our breast tumor, that is breast tumor in malignant or benign. So malignant and benign, these are the two class of that tumor. So let's see the shape of our dataset. Our dataset contain 569 rows and 32 columns. Now we are going to encode our target variable by using label encoder command. Our target variable is malignant and benign. We convert it into 1 and 0. So for that we have to run this command. So let's execute our code. Our target variable is converted into a numerical variable, that is 1 and 0. You can see here malignant is 1 and benign is nothing but 0. It is encoded into numerical variable. Now we are going to make a data frame of our remaining data set. That is our data set containing 32 variables. We are trying to remove our id variable and our target variable from our data set and make a data frame of all remaining columns, that is remaining columns are 30 and all 569 rows. So here id column is removed and target column is separated from our original data set. Now we see why we have to go for dimensional reduction. For that we check the multi-congruity of our data set, that is nothing but high correlation between some variables is present in our data set. That's why we have to check multi-congruity. If our data set consists of multi-congruity in between some variables, then we have to go for dimension reduction, because when we fit directly any model on that data, then there will be a overfitting or underfitting of model. So that's why we have to go for dimension reduction. Then we have to apply some models on that reduced data. So first of all we check multi-congruity by using a seaborn library. Here we plot a correlation matrix by using seaborn library. So let's execute our code. This is the required code for obtaining the correlation matrix using seaborn library. So you can see here, this is our required correlation matrix, consists of 30 variables, and this is the correlation matrix between them. Yellow color says that there is high correlation, and here we can see this is blue color says that there is low correlation. When there is yellow color, there we can see the diagonal elements having higher correlation, it is these elements having higher correlation, and some of the part of this correlation matrix colored by yellow and greenish. That's why we can say our data set consists of high multi-congruity, that is high correlation between the variables, because most of the part of our matrix is colored by using this green, that is correlation between 0.6 and 0.8. you can see here greenish part, here again greenish part. So here you can see, we can say that there is high multi-congruity. Again we try to obtain our correlation matrix by using heat map. So here this is the required code for obtaining the correlation matrix using heat map. So our code, here we can see this is our correlation matrix. These are the variables, that is 30 variables, and this is the correlation between these two all these variables. We can see the darker region consists of high multi-congruity, and most of this correlation matrix having darker region like this chocolate darker region. That's why we can say that our data set consists of high correlation between the variables, as well as then we can say that there is multi-congruity between the variables. That's why we have to go for dimension reduction. After that reduced data, we apply some models on that. First of all, we use principal component analysis for dimension reduction. For that we import PCA library. and standard scalar library for scaling of our dataset. So let's import all these libraries. Our code is executed. Now we scaling our dataset by using standard scalar command. Here we can see this is the required code for that. Now we run our PCA model on our scale data. Our model is executed here. Now we can see our new data, that is now PCA data. Here we can see these two components are nothing but principal components, and this is our required data obtained from dimension reduction using PCA of our original dataset. Let's try to visualize our PCA data in 2 dimension. We can see here this is our 2-dimensional PCA reduction data. We can see here most of the blue and yellow points are overlap. So this is our required visualization of principal components of our PCA output. So this is the yellow class is, we can say that it is malignant, and blue is benign. So let's see the 3D visualization of our dataset, of our PCA dataset. This is the required code of 3D visualization of our PCA dataset. So we can see here this is our 3D visualization. So here again we can see some of the points are overlap on each other, yellow points and blue points. Again we split our try to make data frame of our PCA dataset and try to split it in training dataset and testing dataset. Now we use our reduced data, that is nothing but PCA data. Reduced data nothing but output of PCA. We can use it for our further analysis. That is nothing but we try to apply some machine learning models on that PCA data on the behalf of our original data. We don't apply it on our original data. We try to apply it on reduced data, because our data set consists of multi-quantity. First of all, we reduce it and make a new data, that is nothing but reduced data, that is output of a PCA, and try to apply some models on it. So first of all, we split our PCA data, that is nothing but reduced data, in training and testing. So let's execute our code. Our code is executed here. Our dataset split into 70% of training data and 30% of testing data. Now first of all, after splitting, we try to apply decision tree classifier on this reduced data. That is first model, decision tree classifier. So we can see here now our this is our required output obtained from decision tree classifier. Now we see the accuracy of our data model of that is nothing but decision tree classifier on our reduced data. Our data our model consists of 87% of accuracy. Now again on the same data we try to apply KNN classifier, that is nothing but K nearest neighbor classifier. This is the required code to apply K nearest neighbor classifier on PCA data. Our code is executed here. Now we try to see our accuracy score. This 91% of accuracy when we apply KNN on PCA data, that is nothing but our new data, reduced data obtained from PCA. Now we apply bagging technique using different base classifiers. So first of all, we try to apply bagging using K nearest neighbor as our base classifier. First of all, we try to see the accuracy of all these models. That is nothing but these are our two models, that is decision tree classifier, K nearest neighbor classifier, and this is our bagging technique classifier. Here we can see in this bagging technique, first of all we use K nearest neighbor classifier. So here our bagging code is executed. Now try to see our bagging output, that is nothing when we use base learner as a K nearest neighbor. We can see our accuracy is 87.71%. Now again we change the base learner. We use try to see the base learner is decision tree classifier. Here we try to see the accuracy of this after changing the base learner of bagging technique. Now our code is executed here. Now we can see the accuracy of this model by checking the accuracy score. Our model consists of 87.13% accuracy. Now again we change the base classifier, that is nothing but base learner. Here we use support vector classifier as a base learner and try to see the accuracy score. In this tutorial we can see this is the third bagging model, that is nothing but here we use base learner as a support vector classifier. So try to execute. Now our code is executed and see the accuracy score. Our accuracy score is 68.42%. So this is our accuracy score by applying this third bagging model. Our bagging model consists of 3 models by changing the base learner. First of all, we apply bagging technique using k nearest neighbor as a base learner, that is weak learner. Another model consists of bagging technique consists of decision tree classifier as a base learner, and third model of bagging consists of support vector classifier as a base learner. We try to see the accuracy using these 5 models, that is nothing but first of all decision tree classifier. Again we apply decision tree classifier on reduced data. Again we apply KNN classifier on this reduced data, and again we apply an assembling technique bagging on this reduced data using different base classifier. Again here we can see we apply it on PCA. Now in the second part of this tutorial we are going to apply same procedure on tsne, that is second dimension reduction techniques. In this tutorial we apply PCA techniques, and again we use it for further analysis. We use reduced data technique PCA. We use PCA output for further analysis, nothing but applying these 5 different machine learning models. In the second tutorial we try to apply these 5 different model on reduced data by using tsne, and try to compare the accuracy between these 5 models apply on PCA and 5 models on apply on tsne. Try to compare the accuracy between these two processes and see which process is better for our data set, and try to see the which method is used for in which situation. So thank you all of you. So hit the bell icon for my latest new videos, that is you can get notification when you hit that bell icon. So thank you all of you. If you want to know what is the comparison in which situation we use which dimension reduction techniques, so you have to see our next tutorial, our next part of this tutorial. So thank you all of you. Hit the bell icon for my latest videos notification. So thank you all of you.